Groundwater, not only can it be a resource that we can use for irrigation and for drinking water supplies, but it can be a hazard. One of the areas that's of most concern is along the coastal flat land where groundwater can get pushed by the sea and the groundwater can push the sea back. And of course, all along the coast with sea level rise coming, we're concerned about the potential for the sea to lift the groundwater and change its position. When we're looking at these coastal problems, we need to understand firstly the natural system, and then what is the effect of the urban development and how much is that changing the natural system. South Dunedin is a great example where the whole system has been affected by urban development. Well, we're out here at Moanarua monitoring piezometers. Groundwater flows into the pipes and fills them up. So what I'm going to do here is to measure the level of the groundwater with an electronic tape measure. And when I lower it down, it will eventually beep when I hit the water. There we are, 2.6. So this is another of our piezometers in the network. We've got 23 of them across the city. And this one's on a low-lying part. And if I drop this tape measure into the bore here, I don't have to go far at all. In fact, I've hit the water there, just 50 centimetres down, less than half a metre. We have saturated ground. So in each of these holes, we have an electronic pressure transducer. This is one here, hanging in the hole, and they measure the water level and how it goes up and down over time by taking a recording every 15 minutes. And we measure how much it changes when it rains or when the tides are moving. At this site here, we have about a 1 centimetre shift. When the sea over there, a kilometre away, moves up and down a metre, here we move about 1 centimetre. And we measure all the changes during the seasons, all through the year, using these pressure transducers, which give us an idea of how much the groundwater is moving from site to site across the city. In New Zealand, we have a problem with the shallower the groundwater, the higher the potential for liquefaction during earthquakes. And we saw that in Christchurch, that the very shallow areas where the groundwater was very shallow were, experienced very, very bad liquefaction. As groundwater rises, it can then start to flood into basements and subsurface structures, and it can get in and start to rust concrete reinforcing and saturate things. There's also the fact the rising groundwater exacerbates these other problems. So as it comes up, it means there's less room there to store water that would infiltrate from the surface. So it exacerbates the flood in estuaries or flooding in rivers. And then there's other wider issues. Generally, if you're living on land that's very saturated, your houses will be damper. So you get condensation and mildew and problems inside, which have corresponding health problems with respiratory illnesses and things. As groundwater rises, the ground's often a lot softer and behaves differently, and can behave quite differently when it's saturated in terms of its geotechnical properties. So you have to design accordingly, particularly if you want to build a hospital or some school or one of these structures where you need a better foundation design. In Dunedin, we have suburb scale kilometres by kilometre where there's some places that are worse than others and some places which are more exposed to the potential effects of sea level rise than others. And if we go to Christchurch, we have quite a different setting. We have there the rain is not as important. Certainly during the summer, if it rains, the pavements are often hot and it evaporates and not so much water goes into the ground. we get groundwater flow coming down from the Canterbury Plains, and the springs come out forming the Avon, and they drive where the groundwater is high. So these suburb scale things are really important when we get down to trying to look at the risk. And our real worry for the future of South Dunedin is this relationship between the groundwater coming up and the surface water coming down, and having less room to store that water in the ground. It's dependent partly on the geology, but it's also dependent on how much the groundwater responds to the push from the sea level. And that's what we've been trying to find out when we're doing all of this work with the boreholes. So what we're trying to understand is the natural changes to the groundwater system. The groundwater goes up and down depending on the geology and the forces of rain coming on top and the sea pushing in the side. And there's that natural fluctuation. And on top of it, we've constructed a city. And so we modulate the natural system with the urban environment. Having roofs and drains and hard street surfaces has an effect. So what we're trying to do with this project is to use South Dunedin to understand that relationship between the natural system and the urban system, and how much it's been modulated. And what does that mean for the amount that we're going to have to do that in the future? What sort of engineering solutions do we need in order to be able to maintain this land and use it in the future?